Imagine a silent, metallic messenger, no larger than a compact car, screaming through the absolute freezing void of interstellar space at a staggering 38,000 miles per hour. As of today, February 26, 2026, this machine, Voyager 1, has been hurtling through the dark for nearly half a century. It is 16 billion miles away, yet in the grand, terrifying architecture of the cosmos, it hasn't even left our front porch. You see, theoretical physicists have just crunched the numbers for a trajectory toward the Andromeda galaxy, and the result is nothing short of devastating. 44 billion years. Look at that number, 44 billion years. That is not just a long time, it is a direct confrontation with the impossible. The entire universe, from the Big Bang to this very moment in 2026, has only existed for 13.8 billion years. To reach our nearest large galactic neighbor, Voyager 1 would need the universe to live through its entire lifespan, from birth to death, more than 3 times over. We are talking about a journey that outlasts the stars themselves. It is a mirror held up to our species, reflecting a scale so vast it threatens to render our greatest achievements into mere whispers in a hurricane. Why is this happening? Why is the gap so insurmountable? NASA logs confirm that by November of this year, 2026, Voyager 1 will reach a milestone that defies the human imagination. It will be 1 full light day away from Earth. A command sent at the speed of light, the ultimate speed limit of the laws of physics, will take 24 hours just to reach the craft. But even light itself, moving at a blistering 186,000 miles per second, requires 2.5 million years to cross the gulf to Andromeda. Voyager, by comparison, is a primitive snail crawling across a continent. Theoretical frameworks like the Kardashev scale suggest we are barely a Type 0.7 civilization, still tethered to the slow-motion physics of the 20th century, while the universe expands away from us at a pace we cannot hope to match. Think about the irony. This machine, assembled by human hands in the 1970s, possesses less computing power than the key fob in your pocket. Its brain processes a mere 8,000 instructions per second. Your modern smartphone handles roughly 14 billion. Voyager's entire cognitive architecture is ancient, a relic of a bygone era. Yet, fueled by a decaying lump of plutonium-238, it is the only piece of human intelligence currently navigating the interstellar medium. NASA technicians at the Jet Propulsion Laboratory are still receiving its data, filtered through a 24-hour delay that mocks our need for instant gratification. We are witnessing a forensic trail of our own limitations. If the distance to Voyager is the width of a human hair, the distance to Andromeda is a football field, and we haven't even taken the first step. But here is where the official narrative takes a sharp, suspicious turn. While we calculate Voyager's futile journey, the Andromeda galaxy is actually coming for us. Telemetry confirmed as recently as hours ago shows Andromeda hurtling toward the Milky Way at 110 kilometers per second. Recent simulations run at the University of Helsinki using the latest data from the Gaia Observatory suggest a chaotic gravitational dance involving the Large Magellanic Cloud. We aren't just looking at a craft drifting away. We are looking at a galaxy-scale forensic event that will warp the very fabric of our night sky. The question isn't just how long it takes Voyager to get there. The question is, what will be left of here when the countdown finally reaches 0? You see, The sheer mathematical brutality of interstellar space is a wall that no chemical rocket can ever climb. When NASA launched Voyager 1 in 1977, it was designed for a 4-year mission, a quick flyby of Jupiter and Saturn. It was never intended to be our ambassador to the stars. And yet, it survived. It crossed the orbit of Jupiter. It weathered the radiation of Saturn. It screamed past Pluto. And in August of 2012, it did the impossible. It crossed the heliopause. It left the protective bubble of our sun's solar wind and entered the interstellar medium. It is now drifting through a region so incredibly empty that the nearest particle might be miles away. Imagine the loneliness of that craft, a lump of metal built by people who are now mostly gone, drifting through a silence that is absolute. If you pointed Voyager toward Andromeda tonight, you are committing it to a voyage through the deep time of the cosmos. By the time it covers even a fraction of that distance, the Earth as we know it will be unrecognizable. The continents will have shifted, the climate will have transformed, and our very species may have evolved or vanished. 44 billion years is long enough for the stars themselves to exhaust their nuclear fuel and go dark. And yet, despite this devastating math, we persist. We calculate these travel times not to discourage our spirits, but to sharpen our curiosity. We look at the one light day milestone approaching in late 2026, and we realize that we have achieved something profound. We have extended our reach beyond our own star. We have sent a message into a bottle and thrown it into an ocean so vast that the other side is practically a myth. The physics says it is impossible. The math says it is futility. But the human spirit says we must try anyway. We must continue to audit these telemetry logs. We must continue to listen to the faint whispers of a 48-year-old computer. Because in those signals, we find the proof that we were once here. But beneath the cold mathematical despair of 44 billion years lies a secret that is far more haunting, far more human. Bolted to the side of Voyager 1 is a 12-inch gold-plated copper record, a cosmic time capsule known as the Golden Record. As of February 26, 2026, this record remains the most durable monument to our existence, a testament to the brief moment we occupy the stage of the universe. Theoretical physicists suggest that this disk could remain readable for over 1 billion years, outlasting our oceans, our atmosphere, and perhaps even our species. You see, Carl Sagan and his team weren't just sending data. They were sending an emotional forensic footprint of a civilization. They encoded greetings in 55 languages, ranging from the ancient guttural sounds of Akkadian spoken in Sumer 6,000 years ago to the modern dialects of 2026. They included the laughter of children, the sound of a mother's kiss, the complex songs of humpback whales, and 90 minutes of the most diverse music our planet ever produced. From the structural perfection of Bach to the raw energy of Chuck Berry, it is all there, etched into gold and flung into the eternal dark. But there is a specific detail in the telemetry of this record that wrecks the clinical coldness of the mission. Encoded within the scientific data is a 1-minute compressed recording of the brain waves and heartbeat of a young creative director who had just fallen in love. As you sit here in 2026, 16 billion miles away, the electrical signature of human love is drifting through a region of space where the temperature is near absolute zero. It is a staggering thought. Long after the sun has swelled into a red giant and consumed the earth, the sound of a human heart skipping a beat will still be traveling through the silence. Yet, as we audit the current 2026 data, we must confront a disturbing reality. While the record is designed to last a billion years, the journey to Andromeda is 44 times longer than that. Even if the golden record survives the radiation of the interstellar medium, the distance to our nearest galactic neighbor is so vast that by the time Voyager 1 reached the outskirts of Andromeda, the Milky Way might not even exist in its current form. The two giants, our home and Andromeda, are currently locked in a gravitational death grip, hurtling toward each other at 110 kilometers per second. Official NASA logs and recent studies from the University of Helsinki have injected a new layer of productive paranoia into this narrative. Using 100,000 simulations and data from the Gaia Observatory, scientists discovered that the collision isn't a certainty. The Large Magellanic Cloud, a satellite galaxy visible from the southern hemisphere, is tugging at us. Its gravity is acting like a cosmic anchor, potentially dragging the Milky Way off its collision course. We are living in a universe that is constantly shifting, where even the arrival of a trillion-star galaxy can be diverted by the ghost-like pull of a smaller neighbor. Imagine the night sky of the distant future. If the collision occurs, it won't be a crash of solid objects. Space is too empty for that. Instead, it would be a slow, multi-billion-year ballet of gas and fire. The gravity would stretch both galaxies into enormous tidal tails, triggering a firestorm of new star formation that would turn the night sky into a blazing tapestry of nebulae and newborn suns. And yet, for Voyager 1, none of this would matter. The craft is on its own trajectory, a lonely sentinel that would likely drift through the gaps between these merging giants without ever touching a single star. Why does this matter to us today, in February 2026? Because it forces us to redefine the meaning of success. We built a machine with the computing power of a toy, powered it with a lump of decaying plutonium, and sent it into a void that defies comprehension. We knew it would never reach Andromeda. We knew it would never see another star in any human lifetime. And we did it anyway. That is the intellectually aggressive truth of our species. We do not explore because it is easy or even possible. We explore because the very act of reaching out justifies our existence. As the clock ticks forward in this February 2026 audit, we must face the ultimate chilling destination of our interstellar messenger. In approximately 40,000 years, Voyager 1 will drift within 1.6 light-years of a dim red star known as Gliese 445 in the constellation Camelopardalis. But it will not stop. It will not slow down. It will simply scream past that distant sun and continue its eternal transit into the heart of the Milky Way. You see, Voyager 1 is no longer a spacecraft. It has become a ghost, a relic of a Type 0 civilization that dared to scream into the hurricane of the infinite. The forensic reality of the situation is this. Even if Voyager 1 avoids a collision with a rogue asteroid or the gravitational pull of a black hole, its mission will never truly end. It is committed to a journey that spans the life and death of the stars themselves. 44 billion years from now, when the journey to Andromeda would finally be complete, the very atoms of the craft might be all that remain of the human story. Theoretical physicists suggest that by then, the era of star formation in our local group will have ceased. The universe will be a darker, colder, more lonely place. And yet, that 12-inch gold-plated copper record will still be there, carrying the laughter of people who lived on a blue planet that no longer exists. But wait, there is a final, staggering twist in the 2026 data. While we calculate these devastating travel times, we are ignoring the possibility of a technological leap. According to Alcubierre metrics and emerging theories on non-Newtonian propulsion, the 44 billion year sentence only applies to the technology of 1977. If we eventually master the warp drive, the ability to bend the very fabric of space-time, we could potentially catch up to Voyager 1 in a matter of days. We could pass our own messenger, wave at the golden record as we streak toward Andromeda at 10 times the speed of light, and leave the ghost of 1977 in our wake. This is the intellectually aggressive truth of our era. Voyager 1 is both a tragedy and a triumph. It is a tragedy because it highlights our current fragility, our inability to cross the cosmic street without spending billions of years in transit. But it is a triumph because it is the first time a conscious mind has successfully survived the departure from its home system. It is the proof of concept for our immortality. In 2026, we aren't just looking at a probe. We are looking at our own forensic footprint in the heavens. We must understand that the universe is not indifferent to us because it is cruel. It is indifferent because it is vast. The same physics that makes Andromeda unreachable also made every atom in your body inside a star that exploded billions of years ago. You are not a spectator in this cosmos. You are the universe looking back at itself, trying to understand the distance. And the fact that you are here in February 2026, thinking about a machine 16 billion miles away, means that curiosity has not been defeated by scale. It has been sharpened by it. Long after our sun has died and the earth is gone, that little gold disk will still be out there. It will still be carrying the sound of thunder, the smell of rain, and the heartbeat of a woman falling in love. It is a cosmic bottle thrown into an infinite ocean, and even if it never reaches the other shore, the fact that we threw it is the most beautiful thing we have ever done. We are a species that refuses to stay silent in the dark. We are a species that builds monuments out of gold and plutonium. And as Voyager 1 continues its 44 billion year odyssey, it carries with it the final audit of humanity. We were here, we were curious, and we loved.